Hi, welcome back to our third video for 6.7 geometric series. In this example, we're going to look at example number 3. It says determine the sum of each geometric series. So all these questions are similar. We usually ask to find the geometric series. What makes each one different is the information that's given in the question. So in this one, we have our sequence, our geometric sequence, or series, because we're adding all the terms together. And the thing with this one is we don't know n, right? We don't know how many terms there are. And when we want to find the series, n is one of the things that we need to find. Okay, this is our general formula that we want to use. And I can see a, that's my first term, right? So we have a equals 32. And I can see my common ratio. We'd be multiplying by a half each time. So r is 1/2. So I got A and R. I just need N in order to find this series. So I need to know how many terms there are. So luckily, we know our explicit formula for the geometric sequence. So that is A times R to the N minus 1. So the first term is 32. I'm just going to calculate this right now. R is 1/2. And we have N minus 1. So our last term in the series, that'll be our nth term. That's going to be the value of T of N. It's going to be 1/8. Okay, so now we're trying to find the exponent here. That's how we're going to find n, the number of terms in this sequence. So we'll need to divide out 32 first. So divide that side by 32 and then divide this side by 32. So we're actually going to have 1/8 times 32, which is going to give us 1/256. So that's going to be equal to 1/2 to the n minus 1. Okay, so again, at 256, I got that because we did 1/8 times 1/32, right? So dividing by 32 is the same thing as multiplying by 1/32. So 8 times 32 gives us the 256. All right, so how can we find n now? Well, this won't be too hard. We can just rewrite this as a power with a base of 1/2. So 1/256 is equivalent to 1/2, and I believe it's to the 8th. Okay, yeah. Yeah, because we have 2, 4, 8, 16, 32, 64, 128, and then 256. So yeah, that's 8 times. Um, so that has to be equivalent to 1/2 to the n minus 1. So you can see how these are equivalent. And I could rewrite this as 1/2 to the 8, put the exponent up there. That's the same thing. And it looks more appropriate because now I have two powers that are equal, right? A power here and a power here. They're both equal, and they both have the same base. So if they have the same base and they're supposed to have the same value, that means they should have the same exponent. So I'm just going to equate those, add the 1 to both sides, and we get 9. So there must be 9 terms in this series. Okay, that's great. We're going to go ahead and we're going to take this 9 and we're going to plug it in for n up there. So we're looking for the series for the 9 terms. Our first term is 32. My common ratio is 1/2. So I'm going to make a square bracket out of this. I'm actually going to move this over a bit to get a little more space. And we'll do 1/2 to the n. N is 9. Then we have minus 1. And then we have 1/2 minus 1 here. 1/2 to the 9. Well, 2 to the 9 is 2 times bigger than 2 to the 8, which is 256. So we can double that. I know that's going to be 512 minus 1. It's going to be, sorry, 1/512 because it's 1/2 to the 9. So if I'm just doing 2 to the 9, that's right here. And this is all over 1/2 minus 1 is -1/2. Okay. I'd like to clean this up. 32 divided by -1/2. That means multiply by -2. And we're going to get -64. So we have negative 64 times 1 over 512 minus 1. So I got to get a common denominator. So that 1 we're going to rewrite as 512 over 512. So we have negative 64 times negative 511 over 512. So negative 64 over 512, I can simplify that to 8. So let's clean this up a bit. We have two negatives being multiplied together, so those are going to cancel. Cross those out. And then 64 over 512. 512 over 64 is 8. So I can cancel that out, and that reduces to 8. My final answer is 511 over 8. So that is my value for that first series as an exact number. All right, part B, we're going to do the same thing for part B. So we're going to have to create a little bit of room. Try that again. Okay, there we go. So we're doing the same thing. We want to find the series. We need to know n first. So let's use our explicit formula. So we know that a is 1. We know that r in this case, what am I multiplying by to get the next terms? So it looks like r is negative 3, right? Because we have times negative 3 to get the next term. All right, and our last term is negative 243. We're trying to find n, right? So that's our given, and this equation is going to work perfect for that. We'll sub everything, and we'll solve for n. So negative 243 equals a is 1, r is negative 3. I don't know the exponent, but I will pretty soon. So it's real easy. The 1 here, might as well cancel out. It doesn't mean anything. So we kind of have everything written the way we need to. So I like to rewrite this as a base of negative 3. So negative 3 to what exponent gives me 243. So I know 4 gives 81. 81 times 3 would give us 243. So that would be a total of 5. So for this to be true, n must be 6, right? So we have two powers that are equal. They both have the same base, so that means their exponents are equal. So set them equal, and then solve for n. So add 1 to both sides, n is 6. So there's 6 terms in the series, so we're going to find S6. Formula is a times r to the n minus 1 over r minus 1. First term is 1, so we don't even really need to put anything for that. The common ratio is negative 3, so negative 3 to the 6 minus 1. Let's make that a square bracket over negative 3 minus 1. So negative 3 to the 6, that's actually going to be 243 times another negative 3. So that will be negative 3 to the exponent 6. This isn't the proper way to write this, by the way. There should be a bracket here. It's not going to change the value, though, but actually it does because it's an even exponent. So yeah, we do need those brackets for sure. So that's going to be a positive 729 minus 1. So on the top we have 729 minus 1 over negative 4, which is going to be 728 over 4. So that's going to work out to, it's negative 4 on the bottom, sorry. 728 divided by negative 4, I think it'll be about 182, I believe. Negative 4, yeah, negative 182. All right, so that's our our series, our geometric series for part B. Okay, hope you found this helpful. We just have one more example left. I'll see you in the next video.